Now, today we are really talking about how to obtain a flexible production. So how to have accuracy and efficiency of a production schedule, of course, has a huge impact on the business results. So to create a good production plan is very important, and we need to take into account all the different constraints that we have in production, like material availability, the capacity of the line, the machine, the demand, the supply, the operator availability, and so on. So all these constraints are actually not static, so are something that continuously change. And so if we want to operate effectively, we need to have a plan that is adapting to this change as well. So on top of that, a lot of industry are going in the direction to have configurable products. So products that are more and more different each other, a kind of mass customization. And this, of course, is also increasing all the constraints that we need to apply to our production plan. And now, if you go next. So now, this is the situation we are living today. Of course, the current crisis has shown that unexpected changes in demand and supply can happen and really bring the entire supply chain under chaos. So now is even more important now to have the possibility to map the constraints, to have the capability to understand, first of all, what is happening, and also adjust the operation accordingly is now becoming really vital for managing the production in a flexible way. And this is what Marco will talk about in the next session. So we'll really tell us how all these things can be considered dynamically in a tool, and how we can really win the scheduling game for smart manufacturing. So please, Marco, keep going.
Thanks, Fabio, for the introduction. Welcome, everybody. My name is Marco Lentini. I'm practice manager for supply chain management in USA. So today we are focusing on OP Center APS. OP Center APS is a suite of software that cover finite capacity production planning and detailed scheduling. So first of all, let's make a little bit of clear what's the difference between scheduling and planning. Planning, the first difference is horizon. So planning is aimed to fix problem and give solution and give answers to what's happening in the next 6 months, 1 year, so long range period, less detail, but basically answer question as what to make, where to make it, how much to make it, and when to make it. Scheduling, on the other side, is focused on much more detail and less time horizon. So it's more focused on what's the best sequence to produce to accomplish my production plan, what's happening on the production floor, and how can we react, and so on. To do that, we have to create our model. The model is composed by a mix of your resources, your constraint, your processes, and your calendars. Okay, and mix them together, we can compose this model that give us one main target, that is our focus always when we schedule, that is to give a feasible production schedule and executable by the production line. Okay, so our main focus of the detailed scheduling is to give a truly feasible, executable production schedule. What means with the executable means that all the constraints are respected and my production line can start with the next operation that is highlighted by my schedule, my production plan. To do that, we collect data from different sources. The two most important ones are the ERP and the MES or SCADA system, or some kind of control of the production floor, where we can get from the ERP system, we get orders, and they can be production order, sales order, work order, purchase order, any kind of order. stock availability, calendars, people, and actual availability of things. On the other side, from the MES or a production floor controller tool, we can get updates on how our order are being executed. So there is a breakdown on the line. My order is in time, is early, is late. So that to mixing all this information, we can produce our schedule, our production schedule, our production plan, depending on how you call it on in your company, that is both executable, and we can send it also back to our ERP to update the demand, to keep in contact with the customer, so the customer can be aware of what's happening and how is going to be fulfilled this demand. Okay. So my plan for today is to walk you through 5 different scenarios, 5 different use cases to show you how your company can leverage this tool to accomplish a better production plan and a better production schedule. Okay. My first use case is what's called setup minimization. As the title says, setup minimization is one of the logic that we can use to schedule. What I mean by that, when we schedule, we use different logic, different algorithms, different heuristics, depending on the tool and the capability, that have different target in mind. We can target an early delivery date, like the first case in my slide, where we try to accomplish our need date as a first, or we can try to optimize our processes and try to minimize our setup, like the last case. Obviously, rarely these two extreme are the right answer for any company. Usually we go in the middle to get a compromise to understand what's the best solution for your company. And with that said, I would like to switch directly to the tool so we can see live what it looks like. Okay, this is the Gantt chart of Epicenter ATS, and we can see that we have all our resources here on the left. We have the time going from left to right in a continuous mode, and we have information about supplies here on the header and about demand here on the bottom. We have a list of unscheduled operations, and what we can do is take them. Automatically, the system knows where an item can be produced and where not, as you can see, and we can drop it and schedule it according as we like. Okay. And we can go on, and the system is taking into account all the constraints, the calendar. As you can see, the light blue or gray is when the machine is off, so it's the calendars and so on. Obviously, this is quite time consuming, and I would suggest it. So what we can do is utilize and leverage the automatic logic that I was talking about. Okay, so we have a list, we have forward sequences with different options, backward sequence with different options, bidirectional sequence that's mostly used for bottlenecks, and advanced rule. Okay, for example, let's try to do the most standard one, forward by priority, and we see that our production plan is filled in less than a second with all my order. And if I click on an order, I can see where the order, all the operation of the order, and to which other order is linked this order. So for example, order 18 produces the item Z and is going to fill order 15 that produces item C3 that fills 2 different purchase order here. Okay, but we'll see that in a minute. Let's focus for a second on the scheduling logic. So with this logic, so I want to schedule first what has more priority. I get, for example, 22 order lays, a total setup time of 18 days and almost 19 days, and a schedule span that is from the first order to the end of the last order